So the first question says, find the compound interest on rupees this much at. So we are going to write down the quantities that we know. Here we know the principal is rupees 6,000. The rate of interest is 15% and the time is 2 years. This is compounded annually. Okay, so we know the formula for amount was p whole into 1 plus r upon 100 to the power n, and it is basically our time. For ci we had a minus b, so we've tried to find the a first, which becomes 6,000 1 plus 15 by 100 square. Solving this further, we would get something. Remember, we learned about this. So this much, and then this would give us, don't try to multiply the terms or get the squares first. Okay, just expand everything and keep it till the end. Now here, if you watch, we can cancel out two zeros with 100 and then one zero with from this. So finally, what are we left with? We are left with 6 multiplied 115 multiplied 115 by 10. Now we have to multiply these three terms, and when multiplying this, I'm not going to do the multiplications here, so I'm just going to write down the final answer. Okay, so 6 times what, let's take first 6 times 115. It would give us 690, and then again multiplied by 115. Now see, we have a 10 here, so this 10 would cancel out this, right? So we are left with 69 multiplied by 115, and this would give us 7935. So this was our amount. So what would my CI compound interest be? 7935 minus 6,000, and that would be how much? Rupees 1,935. So my compound interest is 1,935 rupees. That's it. Okay, let's move to the second question. So the second question says, find the amount in the compound interest on rupees this much. Okay, again same drill. We write down the principal, which is rupees 2,500. We write down the rate, which is 10% per annum, and then we write down the time as n, which is 2 years, because time is 2 years. Then we need to find the amount and the compound interest. So amount A can be simply found by using the formula that we have learned. Putting the values, we would get something of this sort. On solving this, we would get 110 100 square, and this can be rewritten as, right? From here, what we can do, we can cancel out stuff that we know can be cancelled out. So these zeros can be cancelled out, this can be cancelled out with this, and this can be cancelled out with this. So what am I left with finally? I'm only left with 25 multiplied by 11 multiplied by 11. We know the multiplication of these two is 121. So 25 multiply 121. On multiplying this, what would we get? So okay, I'm not going to again multiply, or I can do the multiplication here. 5 times 1, 520, 242, 5203. So the product should be somewhere around 3025 rupees. So this would be my amount. And then we can find the compound interest by subtracting the principal, that is 2500 rupees. So the compound interest is A minus B, which is rupees 3025 minus rupees 2500, and this would give me rupees 525. So my compound interest in this one would this situation or this question is rupees 525. Got it? So let's move to the next question. Question number 3. John borrowed some amount from his friend Michael at 10% per annum at simple interest. Then he lent it to Michael at the same. John borrowed from his friend. Okay, the question is not exactly what I wanted. John borrowed rupees 10,000 from his friend Michael at 10% per annum simple interest. He lent it to Michael at the same rate, but compounded annually. So this is my error. This name should have been something else. Let's say John borrowed from Michael and lent it to Remy. Okay. So now what I'm going to do is we are going to calculate for John first. So P for John, the principal is rupees 10,000. The rate is 10% and the time is 2 years. The simple interest that he is going to pay would be simply P R T by 100, which would be 10,000 which is 2,000. So for John, the interest paid by John. So this is going to be paid by John. John is going to pay this. Okay. Rupees 2,000. Now how much is he going to receive? So he lent the same amount at the same rate but compounded annually. So now the interest he is going to receive, interest John is going to receive is compound. So now we need to find the compound interest. So compound interest can simply be also be calculated like this: 1 plus r power n minus 1. Now the value of p for us was 10,000, so I'm going to put 10,000 here. 1 plus 10, 1, right? The p was r was 10, t was 2. Now we solve this. So on solving this, this would become this whole thing. This would become what? 100 plus 10, 110. So can I write it down like this? 10,000 multiplied 110 by 100 square minus 1. See, this 0 cancelled out. So I'm left with 10,000 multiplied. Square of 11 is 121 by 10. The square is 100 minus 1. So this can be further solved as 1 by 1. So it will become 100. So 10,000 multiplied 121 minus 100 by, remember we learned this. So now these two zeros can be cancelled out with this. So we'll be left with 100 multiplied on subtracting this would get 21, which is 2100. So the interest he receives is 2100. He receives 2100 and he pays 2000. 2000. So what is his gain basically? His gain is 2100 minus 2000. So 100 rupees 100. Okay, now let's move to the fourth question. A sum of money amounts to this much, so the amount is known this time, rupees 16,900. Time is known to, the rate is given like this, so we are going to convert it. 7 times 3, 21. 21 plus 4, 25 upon 3%. Find the sum. So we don't know the principal. Now, we know the formula for amount is P times 1 plus R by 100 power n. The T becomes n because there are two tiers. It's compounding annually. So now, by putting the values, we would get 16,000. Okay, sorry, we don't know the value of P, right? So it's just going to remain P multiplied. 1 plus R is 25 upon 3. 25 by 3, and the denominator 100 can be written along with 3. Then we have n is 2. On further solving we would see that, okay, so we can do it either way. We can just keep it as it is. So this becomes 300 and this becomes 300 plus 25 square. This can be written as 325 by 300 square. Now, remember I told you no solving unless we are at the last step. So just let's expand it. We know the amount, right? The amount is 16,900. So I'm going to put the value here, 16,900. So at the next step, what do we have? P multiplied by, in the numerator we would have 325 multiplied by 325. In the denominator we would have 300 multiplied by 300. Now simply can we write P is equal to 16900 multiplied by 300 multiplied by 300 by 325 by 325. Now, we can't see that anything can be cancelled out, so we are going to just start dividing stuff. So I'm going to pick up this first. 25 times 4 is 100. 25 times 400, 25 8, 200. 25 times 12, so 13 times. 25 times 13, 25 times 12. 25 times 12, 25 times 13. Then I can also say 13 can be cancelled out with 169 is 1300, and then again 100. So finally what I'm left with is 100 multiplied by 12 multiplied by 12, and this can be simplified further as 12 times 12 is 144 into 100. So the principal amount is rupees 14400, rupees 14,400. Okay, let's move to the next question now. Question 5. So this says a sum of money amounts to this much after 3 years and to rupees this much after 6 years. On compound interest, find the sum. So again, we don't know the principal, but we know the amount after 3 years is 6,000. 690 and amount after 6 years is 10,035. We don't know the rate, we just know the time. These two are time, the amounts we don't know, the rate also. Now both of them are compounded annually, compound interest. So now we are going to try and find the compound interest for 3 years, or simply amount for 3 years. So let's assume P is equal to 100 x. R is simply R. Rate simply R percentage. Okay. So now we are going to find amount for 3 years would be P times 1 plus R by 100 power 3. And this is how much? We know the value, right? 6,690. So this is 6,690. And then we have amount for 6 years. Amount for 6 years. This would be, and this would 10,035, right? Sorry. So yeah, where were we? Now once we are done till this part, we have to now guess the now the there's the trickier part. So I'm going to assume this is equation 1 and this is equation 2. We can do it some other way also, but this might be little easy on the nerves. So now on dividing these two, okay, dividing 1 by, or dividing 2, let's keep the upper larger on as a numerator, by 1. So what would we get? We would see that this whole thing, okay, I'm going to again mark something. So if I assume this thing, this the thing in the green circle is similar in both of them, right? So for now let's assume this edge z. So can I say that here I have p z power 6 divided by p z power 3 is equal to 10035 divided by 6690. And now why do I have a feeling that these two are going to be cancelled out? So yeah, let me check. Okay, so 6690 is divisible by 3. 6 to the 12, 12 plus 9, this is divisible by 3. So let's divide it by 3. Let me do this on the, is it off? Okay, just give me a minute. So what was our number? 10035 10035 So let's divide by 3. 3 times 2, 5389. 3 to the 6, 3 to the 6, 3 3 the 9, 0. 3 3 the 9, 3 3 the 9, 3 4 the 12, 3 5 the 15. Now 3 to 5 have to 7. Now we'll take it by 5. So 5 4 the 20. Again 5 4 the 20. 5 6 the 30. 5 6 the 30. 34. 5 6 the 30. 45. 5 9 the 45. Now again we'll take it down with 2. So 2 times 2 times 3. And oh, we can't, sorry. Oh, but now I, okay, so let's take both of them out by 2 2 3. So 2 2 3 times 2 is 4 4 6, and 2 2 3 times 3. Great. So now we have 3 by 2. So I'm going to write down simply 3 by 2. Now that we are done till this part, can we get back and once again look here? So this g was, and this can also be cancelled out, and the power would be reduced, right? So what I would have is g6 minus 3, g to the power 3 is equal to 3 by 2. And what was g? G was this whole thing. So can I say 1 plus r by 100 cube is equal to 3 by 2? Can I? We can. Now this thing here is exactly this thing, right? So can we put it in equation 1? Using an equation, using this value in equation 1, can I say that p times 1 plus r by 100 cube is equal to 6690 can be rewritten as this whole thing is equal to 3 by 2. So can I just sorry, p multiplied 3 by 2 is equal to 6690, and hence p is equal to 6690 multiplied 2 by 3, 2230, and this would give me that p is equal to 4460 rupees, right? So this is what we have recalculated. Okay, now that we are done with this, we will move to the next question. The next question is question number 6, which is in how many years will rupees this much amount to this at 10%? So the things that we know here is the principal is rupees 1800. We know the amount is 2178. We know the rate of interest is 10% per annum, and the only thing that we need to find is t. So can we say that, can we just use the formula for amount? So my t would be n, right? I'm going to put the values that I know: 2178, 1800, 1 plus 10 by 100. This can be rewritten as 1800 multiplied by 110 by 100, and the zeros would be cancelled out. Okay, cancelled out. So we are left with 2178 equals 1800 multiplied by 11 by 10 to the power n. Now on moving this here, can I write this down as 2178 because I'm dividing both by 1800, and on dividing this side by 1800 I would simply get 11 upon 10 power n. Now let's check if this thing can be written down like somehow like this. So we have 18 here, so I'm going to try and divide this by 18 or 9. Let's divide by 9. So 9 times 2, this would also be divisible by 9, right? So 9 times 2 is 18, 37, 9 for the 36, 18, 9 to the 18. Then again I divide by 2, so 100, and I get 1 to 1. So what have I got here? I'm going to write down. So I have got 1 to 1 by 100 is equal to 11 upon 10 power n. 1 to 1 is 11 square, 100 is 10 square. So can this be simply written as 11 by 10 square, and this thing comes here 11 by 10 power n. So the bases are same, Hence, we can deduce that n is 2. Therefore, time would be 2 years because it's compounded annually, right? Now let's move to the next question. It says, though if the simple interest of a sum of money, okay, we don't know the principal again. At 10% for this is this much, then find the compound interest. So we are going to again take, we don't know the principal, we know the rate. Okay, give it a second. We know the rate of interest is 10 per, okay, why is it lagging? 10% per annum. We know the time is 3 years, and we know the SI is rupees 1500. We need to find the compound interest. We need to find the compound interest. So we need to find the principal stuff first. Now, as we know the simple interest, can we simply use the formula for simple interest? And on solving this, P is, we don't know, R we know, T we know, and 100. So this becomes 10. So P times 3 by 10, and the SI is 1500. So 1500 is equals to P multiplied 3 upon 10. Can this be written as P equals 1500 multiplied 10 by 3? 500, 5000. So we can say that the principal amount is rupees 5000. Now once we are done with finding the principal, we can simply find the compound interest. So now the compound interest can be found as P 1 plus R by 100 power n minus 1. How did we get this formula? I'm going to explain it once again. Because we know A minus B, Ci is equal to A minus B, and A is P whole into 1 plus R by 100 power n. Then we subtracted P from whole of this minus P. Now this is just one term, just something inside the bracket multiplied by P and then P here. We take out the P as a common, so we write down the P here. Now what are we left in the first term? We are left with this much, 1 plus R by 100 power n, this. And in the second term, when we take P as common, we are left with only minus 1. So this is my formula. Now I'm going to put the values that I know. We know the value of P is 5000. We know the rate is 10%. And we know the time is 3 years, I think. Yes, the time is 3 years. So I'm putting 3 here. Minus, we have 1. Now, the first thing that we need to do here is we have a Q here, right? So I'm going to cancel this out and I'm left with 1 by 10. So it would be 5000 multiplied, see, it should become 11 by 10 cube minus 1. And this can be solved further as 11 times 11 cubes is basically 11 into 11 into 11. Remember I told you don't multiply yet. So we can multiply 10 cube because it's simply 1000, right? So I'm going to write down 1000 here. Then we have minus 1. This is all inside the bracket, so I need to solve all of this first. So 1 can be written as 1 by 1. On solving this further, what would I get? I would have this number as it is, the number outside the bracket. Inside the bracket, however, I'll have the denominator, product of both the denominators. Then this would be product of this everything, 11 times 11 times 11. Now what I'm going to do is I'm going to find the product of 11 times 11 times 11. So basically the cube of, the cube of 11. What is the cube of 11? So square of 11 is, we know, 1 to 1. So we multiply 1 to 1 with this and we would get 1331, if I'm not wrong. Let me check. 1 to 1. 1 2 1, so it would, yeah, 1 3 3 1, right? So now I have 1 3 3 1 minus this one would become product of these two, so 1000. If you have forgotten, I'm going to explain this once again here. So the first thing, when we are subtracting fractional numbers, what we do, we multiply. We multiply the denominators to get the denominator. Then we multiply crisscross, and we do the addition or subtraction. Okay. Now, sorry, can this be written like this? This would give me 331 by 1000, and this would give me 5. So this is what I'm going to get, right? 1655 would be my compound interest here. Now, let's move to the next question. That is question number 8. The value of a machine depreciates. You see, so there's another word, depreciates. When it says depreciates, is the value increasing or decreasing? It's decreasing. So remember, we have to account this when we are calculating. Now, we know the rate of depreciation is 10% per annum. It was purchased 3 years ago, so time is 3 years, hence, and it's depreciating per year per annum. So n would be 3. It was purchased 3 years ago for rupees 6,000, and the p was rupees 60,000. So we need to find a. Now, whenever there's depreciation, the formula becomes little different. Okay. So for depreciation, or when the compound interest is deducted, so basically the interest is in deductions, the formula becomes this. So we start with everything. Okay, let's write down the formula that we know. It's P plus, this is the formula that we know, right? But in depreciation, when it's talking about depreciation, this plus becomes a minus. That's it. So we'll have amount opposite. The value of machine depreciates. What is the present value? Present value of the machine A can be calculated using the formula, this one. And we know the formula values of everything, so we are just going to put the values. 60,000, 1 minus 10 by 100 cube. See, now what do we have here? We will be having 60,000 multiplied by 100 minus 10 by 100 cube, and this would give me something like this, 90 by 100 cube, and zeros cancelled out, so I'm left with 60,000 multiplied 9 cube means 9 times 9 times 9, and 10 cubes mean basically 1000. So again 3 zeros gone, so I'm left with 60 multiplied with 9 times 9 times 9. So the cube of 9 is 729. So we have 729 times 60. That would be the current value of the object. So I'm going to multiply it as 7 times 60. 0 9 6 are 54, 4 5 carries, 6 2 is 12, 12 plus 4 16, 6 1 carries, 7 6 42, 4 3. So the current price would be 43,650. Let me check it once again. Rupees. Let me check the multiplication once, okay? 90, 96 of 54. See, I've done a mistake here. 9 6 are 54, 4 5 carry, 6 2 is 12, 2 plus 5 17, 7 1 carry, 6 7 is 42, 43, and then the 0. it would be rupees 43,740. The current price of the, what product was it? Machine. Okay, this is. So let's move to the last question, which is question number 9. This is the annual rate of growth in population of a town is this much. If its present population is this, what was it 3 years ago? Again, now it says the annual rate of growth. So obviously the population is increasing. So we don't know the principal. We know the present population, which is the amount 33275. We know the time is 3 years ago, 3 years, and the rate is 10%. So we are not going to write it like this because we haven't just trying understanding how to solve. I wrote everything like this. So the correct way to solve this question would be, questions like this would be, the annual growth rate 10%, present population, and then we assume that the population 3 years ago be X. Then X, which is B, using formula, or simply we can say relation, A is equal to B times 1 plus R by 100 power n. We can write A is our current population. So the current population is 33275. 33275 is equal to X times 1 plus 10 by 100 cube. And now we can solve this. So obviously this would become X 110 by 100 cube cancelled out. So it would be X 11 by 10 cube. And on this side I would have 33275. Right? Now we know this thing. The value of this is 1331 by 1 to 3000. 33275. So basically x becomes 33275 multiplied by 1331. We could have just left it as it is, and then it would have been easier for us to cancel out. So let's start with, do we see anything that, okay, let me check once, have I done everything correct? So 1331,000, yeah, that means 33275. Okay, now we cancel out. We see if this can be divided by this. So 33275 1331. 3 times 3 ones are 3, 3 is a 9, 3 is a 9, 3 ones are 3. It won't. So 2 times. 2 times. 2, 6, 6, 2. 7 minus 2, 5. 12 minus 6, 6. 12 minus 6, 6. And 2 minus 2, gone. So 5. 6, 6, 5, 5. Now let's say 5 times. So 5 ones are 5, 5 3 is 15, 5 1 carry, 5 3 is 15, 15 plus 1 16, 6 1 carry, 5 1 5 and 6. So what am I left with? 25. So can I simply cross this off and say I have 25 here, and then it would give me x is equal to 25 multiplied by 1000 should be 25,000. So population 3 years ago was 25,000. That's it. Okay, so this was all. Question number 9. This is how we are supposed to write down the whole all the steps of the questions which are languages. Okay, whenever the question is giving context, you have to utilize the context by writing down these statements. 7 and 8, 5 and 6, 1 and 2, and where are 3 and 4? 1 and 2, 3 and 4, 5 and 6, 7 and 8, and 9. Amazing. We are done.